So tackling this one, went with that, and just don't do it all at once. Don't ever try and do everything all at once when you're doing these things. Right, so if I look at this, not A is common. Okay, so I'm going to pull not A out, and then I'm going to AND that with, so on this part of the expression, I've got not B or not C and not A, not A, blank, you wanted to put. And I'll explain my logic of trying to do this, if I could write it down properly. If you see some expressions where you've got 3 terms and 2 terms, and there's something common, you're always going to have a chance of reducing it like this to something that you can then say, ooh, absorption rule. Every time. Alright? That's what you're trying to do. With a fourth problem, we get that a bit. So I've pulled that out, and then that's left me with this, which looks a bit pants. It's actually the absorption rule written the other way around. So if I was just flip that and put B or not B and not C, so what does that reduce to with the absorption rule?
B.
Yeah, it's going to be B.
And not C.
Is that what it is? And not C? Yeah, been happy with that? So through absorption, I've simplified that. So out, that was inside my bracket still. So I've got not A and that. Okay? So I can expand that back out and I get one term. Because that was ANDed, so they're both together. So I end up with that. So that side is reduced to that. So if I do tackle the other side and try and look for common factors again, so in this one, it's A is the common again. Can everyone see that one? So I'll pull A out. Right, so looking at this part, I've got B and not C. And then this bit, I have just got C. So again, I have got 2 terms where I've got normal and knotted. I never know what to call the one that isn't knotted. I always just call it normal. Normal and knotted. Anyone got a better suggestion for the unknotted version of something? No. I'm going to keep calling it normal then. Right, that's an absorption rule. So what does that absorb to?
B and C.
Is it B and C? Or is it B or C?
B or C. Or C, yeah.
Okay, so we absorb it. Was that one right? Was that one an AND or a no?
Or.
Should that have been an OR?
Yeah.
Which makes this slightly different. See, this is where you've got to double check yourself. They ought to let you have the rules in the exam. It's a bit mean expecting you to remember them. Okay, so you keep the sign where the single one was. That's the, well, I say sign, it's not a sign, it's the operator. You keep that operator. So when I expand that, I get or not A and not C. Right, okay, so we've reduced that down. Again, that is still ANDed, so we need to expand that out. So if we put a big all there, we should have A and B, or A and C. So this is what we were trying to get to. So we've got that term's appeared there, A and C's appeared, but we haven't got B on its own. All right. So we need to look to see if we can find common factors again. So we got this one with B in it, and we got this one with B in it. Now the other interesting thing, there's an A and a not A. That's ripe for simplification. So I'm going to grab that one and that term, and I'm going to pull those together using the distributive rule. So I'm going to pull the b out because the b is common. And then I'm going to say, right, well, I've got not a or a. What simplification does that one reduce to? Not or it's normal would always give you what?
1.
1, correct. So that reduces to 1. So we end up with b and 1. So what did we say b and 1 reduces to? B. So b becomes the controller, and if b's 0, it's 0. If b's 1, it's 1. So that reduces to b. So actually, once we've looked at that, we say, right, okay, let's see what we got left. So we got a b, or, and then we add this thing. So not a and not c, and then we got this bit at the end, or a and c. Now they're not identical, but that's just because of the way they're rearranged. So there is a rearranging rule, which basically says, like in maths, if you've got 5 plus 6, it's the same as 6 plus 5. All right. So if you've been given a problem where they say show, because they might do this, they might give you an expression and say show it's this. They'll give you the answer. You know, like you get in maths where it says prove that or something like that. They'll say. So usually Boolean Algebra, prove that this reduces to that. So if you do get that, rearrange it so it's in the same form. So we can just rearrange. So it's the same. Okay. So the key things from that, and why it was complicated, is we were looking to match. See, I could have set those two pairs together, but it hasn't got me anywhere because I just end up with B and C, and that doesn't help. If you've got 2 and a 3, where there's some commonality, you're probably going to get a good chance of reducing something. Okay. Same if you've got a 3 and a 4, which we get on the last expression. When you're doing the absorption, wherever the single item is, that is the operator you keep. Okay? That's how those absorption rules work. It's just noting that you've got the opposite of something. Doesn't matter whether it was inside or outside the brackets. Okay.